If you spend some time studying permutations, or finding the number of ways some number of objects can be arranged in a definite order, at some point you have to ask the question, what happens when you're arranging some number of items and order doesn't matter? This was the cliffhanger question I asked at the end of the video I did on permutations. In that same video, we used the permutation formula for scenarios when we're arranging objects or people and order matters. For example, if we are arranging a family of 6 for a photo, and if 2 people switch places, we have a different photo entirely from the first. In this example, order matters, and changing the order of the people in the photo produces an entirely different outcome. This video will answer the question, how do we determine the number of arrangements of some items when order doesn't matter? First of all, we consider a combination to be an arrangement of n items in a non-definite order, which is another way of saying we don't consider order when counting outcomes. If we're considering combinations, and we re-examine the family photo example, switching the place of 2 people would then not produce an entirely distinct outcome, like it did when we were considering permutations. I want to introduce a new formula for combinations, which looks quite similar to the permutation formula, the only difference being this r factorial in the denominator. We'll unpack this formula, where it comes from, and how to use it in this video. But first of all, if these formulas are so similar, how can we determine when order does and does not matter? It's best to demonstrate this by looking at an example. Let's say I get dealt 5 cards from a standard deck of 52 cards. We know that there are 52 options for the first card. With one of those cards removed, we have 51 options for the second, and so on, and so on, and so on, until the 5th card. I could use the permutation formula to show that there are 52 pick 5 possible ways this can happen. However, if I take those 5 cards I was dealt and I consider them to be a hand, imagine you're playing 5-card poker or something, can I not rearrange those cards and still have the same hand? Does the order they appear really impact the hand I'm dealt? The answer is no. If I take the second card I was dealt and switch its position with the first, I have an identical hand because order doesn't matter when I'm looking at the overall 5-card hand that I was dealt. I can account for these repeated hands by dividing out the number of possible hands that could be repeated. I have 5 cards in my hand, and we know that there are 5 factorial ways of arranging my 5-card hand. 5 possible cards for the first position. Having used one, I have 4 possible cards for the second, and so on, down to the last position in my hand, where I have only 1 card option left. So by dividing by r factorial, I've greatly reduced the number of possible 5-card hands I can be dealt, by not considering switching cards to be a distinct hand. To develop a solution to this problem, I can apply the combination formula, subbing in a total of 52 cards for n, and the 5 cards that I'm being dealt for r. My formula would look like this, if order did matter. But because we don't consider switching cards to produce a distinct hand, we divide out the number of ways 5 cards can be arranged. Remember, arranging the cards differently is not considered a unique hand. This expression will simplify into 52 factorial divided by 47 factorial times 5 factorial, also known as 2,598,960 ways a 5-card hand can be dealt. So to summarize, a combination is really just a permutation with the identical cases divided out. That sounds pretty simple, right? Man, can these problems get intense. Not only can it be challenging to identify whether order matters or not, but you can see some pretty crazy applications of this stuff. If this video helped in any way, then subscribe for more mathematical chaos. And as usual, thanks for watching.